So first we will look at just a single spring with a mass attached to it. The top end of the spring is fixed. If I pull this down and displace it, it will move up and down in a regular pattern with simple harmonic motion. The mass is moving at the natural frequency.
This graph shows how the displacement varies with time for the simple harmonic motion that we have just seen.
I've got a motor connected to the string and I can start the motor moving so that the top of the spring moves up and down. With the top of the spring moving up and down at this particular speed, you can see that the mass seems to perform quite big oscillations and then quite small ones.
This graph shows this more complicated motion. It is actually very simple, as it is just the sum of two sine waves.
If I now increase the speed of the motor so the top of the spring moves up and down more rapidly, you can see that the oscillations become very much bigger and bigger and the whole system kind of goes crazy. This is what we would call resonance. If I make the top of the spring go really fast, you can see that the mass stays almost still. The resonance that we saw is not because the speed at the top of the spring is fast, it's because it is matching the natural frequency of the spring mass system, and when this happens we get resonance. I've now attached a rod to the mass, and on the end of the rod is this disc which will act as a plunger, and I'll insert this into a tube of water which will create a damping effect. If I displace the mass and set it into motion, you can see that very quickly, because of this damping effect, the motion dies away.
This graph shows how the displacement varies with time for damped motion.
I will now start the motor. And I will gradually increase the speed. So we can see here that the mass is moving up and down quite a lot, but it is not shaking itself to pieces or going crazy as was the case when we didn't have a damping present. If I increase the speed, so that the forcing frequency is much greater than the natural frequency, the mass almost remains at rest due to the damping effect.